Welcome or welcome back to my channel. In this tutorial, I'll show you how to set up and run a linear static simulation on a piston using Solidworks simulation. This tutorial will help you understand how to analyze the mechanical stress on a piston under applied forces. A piston is a key component in a reciprocating engine. It is pretty much just a solid cylinder of metal that moves up and down in a cylindrical hollow in the engine block. Its purpose is to transfer force from expanding gas in the cylinder to the crankshaft via a connecting rod. Together, the piston, connecting rod, and crankshaft convert the up and down motion into the rotational motion that we can use to power the wheels of a vehicle, for example. I already have the model ready. If you're using your own design, make sure it's fully defined and assembled correctly. Let's start by creating a new study. Click on Simulation, then New Study. Static is selected by default, so just click on OK. Now we need to set up our simulation environment. In the first step, we need to define the material properties. We'll be using AISI 1020, a commonly used steel for structural applications. To do this, right-click here, then select Apply Material to All Bodies. Select this one, click on Apply, then Close. Our next step is to replace the two bolts and the pin with the virtual connectors to simplify our simulation and reduce unnecessary complexity while maintaining realistic behavior. To do that, we need to exclude the parts from the analysis. So select any face from the part so that gets highlighted in the simulation tree. Then right-click on it and select Exclude from Analysis. We will repeat the same steps for the two bolts. Now we need to define the pin connector and the bolt connector settings. First, let's set up the pin connector. Right-click on Connections, then select Pin. Now select these faces. And we should limit both translation and rotation, so make sure to check this box. Then scroll down and check the strength data box. The material is alloy steel by default. Leave it like that. And let's set the tensile stress area to 500 mm². Then validate. Now let's configure the bolt connector. Right-click on Connections, select Bolt, and select these two edges. Now scroll down a bit. The material should be alloy steel, but we can change it by clicking on Select Material. I'm just gonna leave the default option, so just click on Close, then keep scrolling. Check the strength data box and set the thread count to 1.2 threads per millimeter. Then scroll down and set the torque value to 2.5 and the friction factor should be 0.2. Then validate. Now we can repeat the same steps for the other bolt, or we can just copy and paste it. Now right-click on it and select Edit Definition. And replace these two edges with the edges of the other bolt. Then click on OK. And that's it, we've successfully set up the connectors. Now let's move on to apply the necessary loads and constraints. Right-click on External Loads and select Force. select these two faces and set the value to 3500 newtons and make sure to select total. Then click on OK. Now right-click on Fixtures, select Advanced Fixtures, then click on cylindrical faces and select these faces. Now scroll down and select Radial and Axial. Then validate. Now let's move on to the meshing. Right-click on Mesh, select Create Mesh. Then click on Mesh Parameters and select Standard Mesh. Then validate. Okay, now we can run our study. Click on Simulation, then run this study. And there it is. This is our result. But we can animate by right-clicking on Stress, then select Animate. Now let's go back to answer the last two questions. The maximum stress of the connecting rod with 3 decimal places is 831.000. To make it with 0 decimal places, we can right-click on Stress, select Chart Options, then scroll down and set this value to 0. Then click on OK. So this is our result with 0 decimal places. Now to determine the shear force of the pin, right-click on Result and select Define Pin Bolt Check Plot. Validate. Click on Details and here select Pin Connector. And here you can read the maximum shear force of the pin. Now for the maximum bending moment of the two bolts, here you can select the counter bolt with nut, and you can read the bending moment of the bolt here. Same thing for the other bolt, just select it, and here you can read the value. And that's it. This wraps up our tutorial. I hope you found it helpful. Don't forget to comment, like, and subscribe. See you in the next one.